So this simulation shows how the system responds to gas level. First, we have the step block. This is where the input is set. It starts at 0, which means the gas level is safe at the beginning. Then at 5 seconds, the value suddenly changed to 8, which simulates a gas leak. Next, we add noise to the signal so it becomes more realistic, since real sensors are not perfectly stable. Then the step and noise signals are combined using the sum block, so this becomes the final gas level input. Then after that, the system checks if the value is greater than the threshold, which is set to 5. If the value is less than 5, the output is 0, which means the alarm is off. In this case, the first switch select constant 1. Constant 1 means on, so the valve stays open. At the same time, the second switch selects constant 0. This means the shut-off is not active, so normal operation continues. If the value becomes greater than 5, the output becomes 1, which means the alarm is on. Now, the first switch select constant 0. Constant 0 means off, so the valve process. So at the same time, the second switch select constant 1. This means the shut-off is not active. So basically, kapag below 5, safe lang, hindi mag-a-alarm, tsaka bukas pa din yung valve. Pero kapag above 5, nag-a-alarm na siya, tapos automatic na sasara yung valve. So, yung 0 means safe, 1 means alarm. Safe means valve on, leak means valve off. Kapag less than 5, ito yung nangyayari sa signals. Sa alarm, from 1 nagiging 0, ibig sabihin nag-off yung alarm kasi safe yung system. Sa shut-off naman, from 1 nagiging 0, ibig sabihin nawawala yung shutdown, normal operation ulit. Kapag sa on naman, from 0 nagiging 1, ibig sabihin bumubukas yung valve. Kapag greater than 5 naman, ito yung nangyayari. Pag sa alarm, 0 nagiging 1, ibig sabihin nag-on yung alarm dahil may leak. Kumbaga yung threshold nare-reach. So nagkakaroon ng parang leak detected. Nagiging 0. Tapos yung sa on naman, from 1 nagiging 0 dahil ibig sabihin nun, nagsasara na yung valve.
These figures present a simulation of our gas monitoring system from the input signal up to the system's final response. In Figure 1, we have a set input that represents a gas leak. From 0 to 5 seconds, the gas level remains at 0, indicating safe condition. At exactly 5 seconds, the signal suddenly rises to a high value, simulating a gas leak event. Figure 2 shows the noise of disturbance signal. The signal fluctuates randomly, which represent real-world sensor noise. This helps us evaluate if the system can still perform correctly even with stable or unstable input readings. In Figure 3, the gas signal is combined with noise and compared to a threshold. The blue line represents the gas signal, while the red dashed line represents the set threshold. When the signal is below the threshold, the system is considered safe. Once it exceeds the threshold, it indicates a gas leak. After detection, the system generates a response. In Figure 4, the alarm response is shown. Initially, the alarm is off, but once the gas leak or gas level exceeds the threshold at around 5 seconds, the alarm is activated. Figure 5 shows the shut-on response. This indicates once the system detects the gas leak, the control signal becomes active. In the last Figure 6 shows a shut-off response where the signal remains at 1 or on from 0 to 5 seconds, then abruptly drops to 0 or off at a 5 seconds and stays at 0 afterward.